a mysterious concept that humans have tried to decipher since ancient times. It is the measure of change and the endless flow of events. However, does that flow ever end? Modern science has proposed various theories to explain this issue. Some theories suggest that time will end with the collapse of the universe. However, there are other theories that claim time will never end. Any universal concept of time must ultimately be based on the development of the universe itself. When you look at the universe, you are seeing events that occurred in the past because light takes time to reach us. In reality, even the simplest observation can help us understand cosmic time. Take the dark night sky as a practical example. If the universe had an infinite and boundless past, the night sky would have to be completely bright, filled with light from countless stars that have always existed in the universe. For a long time, scientists, including Albert Einstein, thought the universe was static and infinite. Later observations showed that the universe is actually expanding and even accelerating in its expansion. This means it must have originated from a very small state, which we call the Big Bang, implying that time has a beginning. Einstein's special relativity is based on the important fact that the speed of light is constant from any perspective. To apply this in practice, imagine we are driving a car at 32 kilometers per hour and passing by a person standing still. As we pass them, we throw a ball forward at 16 kilometers per hour. As speed combines with the car, however, relative to us, the ball is only moving at 16 kilometers per hour because we are moving at 32 kilometers per hour. Now imagine the same scenario, but this time we pass our stationary friend while moving at half the speed of light. Through some imaginative imagery, that friend can observe us as we pass by. This time, we shine a beam of light out of the car's windshield. In the previous calculation, we added the speeds of the ball and the car to see what the friend observed. So, in this case, would the friend see the light beam traveling at 1.5 times the speed of light? According to Einstein, the answer is no. The speed of light is always constant, and nothing can travel faster than it. In this scenario, both observers see the light beam traveling at its universally agreed value. This is the theory of special relativity, and it is crucial when discussing time. Time, the fourth dimension of the universe. It was once thought that space and time were separate, and the universe was merely a collection of cosmic bodies arranged in 3 dimensions. However, Einstein introduced the concept of the fourth dimension as time, meaning space and time are closely interconnected. General relativity states that space-time expands and contracts depending on the momentum and mass of nearby matter. This theory is well-founded, but all that is needed is evidence. NASA used probes to find evidence for that theory and prove that space and time are indeed linked. 4 gyroscopes were oriented toward a distant star, and if gravity did not affect space and time, they would remain locked in position. However, scientists clearly observed the frame dragging effect due to Earth's gravity, meaning the gyroscopes were slightly pulled out of position. This seems to prove that the fabric of space itself can be altered, and if space and time are linked, time itself can be stretched and contracted by gravity. So, how long is a second? There are 2 main ways to measure time: dynamic time and atomic time. That's the rotation of a distant pulsar, the movement of a star in our night sky, or Earth. However, for a distant pulsar, this can be difficult to observe, and these methods are not always entirely accurate. The old definition of a second was based on Earth's rotation, as the sun rises in the east and sets in the west daily. So a day was arbitrarily divided into 24 hours, 1 hour into 60 minutes, and 1 minute into 60 seconds. However, Earth does not rotate uniformly. Its rotation slows by about 30 seconds every 10,000 years due to factors like tidal friction. Scientists devised a way to calculate the rate of change in Earth's rotation, introducing leap seconds. Atomic time depends on energy transitions in the atoms of a specific element. According to scientists, time can be measured with an accuracy of losing a fraction of a second in 1 million years. The most accurate clock in the universe might be a pulsar, but on Earth, atomic clocks track time most precisely. The entire GPS system in orbit around Earth uses atomic clocks to accurately track positions and relay data to the planet. While the entire scientific center is set up to calculate the most accurate measure of time, usually by measuring transitions in cesium atoms. While most atomic clocks rely on magnetic fields, modern clocks use lasers to track and detect energy transitions in cesium atoms, keeping time more accurately. Although cesium clocks are currently used to maintain time worldwide, strontium clocks boast double the accuracy, while experimental designs based on accumulated mercury atoms can reduce deviation to less than 1 second in 400 million years. Time passes invisibly, but its operation follows rules that humans have yet to fully grasp. Like there's a time deity managing the sunrise and sunset on schedule. And everything that happens on Earth as well as in the lives of beings in the Bowla universe. Time has a beginning, but whether it ends depends on the nature of dark energy that's causing the universe to expand increasingly faster. The increase in this expansion could eventually tear apart the entire universe, forcing it to end in a big rip. Another possibility is that dark energy can decay, reversing the universe back to the Big Bang and ending in a big crunch. Or the universe will simply expand forever. But will these scenarios end time? According to the strange laws of quantum mechanics, tiny particles can randomly appear from a vacuum momentarily, a phenomenon commonly seen in particle physics experiments. Some suggest that dark energy could cause these quantum fluctuations to generate a new Big Bang, ending our timeline and starting a new timeline. Although this is highly theoretical and uncertain, what we know now is that only by understanding dark energy will we know the fate of the universe. So what will be the outcome? Only time will tell. Subscribe to the Ian Nito channel so you don't miss exciting videos.